Hi everyone, welcome to day 7 challenge. Today we're going to tackle the hardest question, number 9. The answers are B, E, and C. Now let's look at the first one. What is the greatest 3-digit positive integer in for which the sum of the first n positive integers is not a divisor of the product of the first n positive integers? Okay, now let's try to interpret this question. The sum of the first n positive integer is n times n plus 1 over 2, and the product of the first n positive integer is just n factorial, and we want n times n plus 1 over 2 is not a divisor of n factorial. And the thing you need to notice is that if n plus 1 is a composite number, and its factors must be less than n, which indicates this expression is a divisor of n factorial. So you need to guarantee n plus 1 is a prime number. And now let's thinking about the greatest 3-digit positive prime number. So that must be 997, and that means n is equal to 996, which is option B. Alright, let's look at the second one. All of the triangles in the diagram below are similar to the isosceles triangle ABC, where AB is equal to AC. Each of the 7 smallest triangles have area 1, and the triangle ABC has area 40. So what is the area of this trapezoid DBCE? Okay, so equivalent to say we're wondering about what is the area of triangle. Let's call it AFG, and then we can just do the subtraction to find out the area. And it's not hard to find that triangle AFG is similar to triangle ADE. And we can try to find out the similarity ratio. So the ratio is just the ratio of 2 line segments, FG to DE. And FG is equal to like 3 times the basis of the small isosceles triangle, and D is 4 times the base of isosceles triangle, so the ratio is 3 to 4. And equivalent to say we can find the ratio of their areas. That is the area of triangle AFG to the area of triangle ADE is equal to 3 squared to 4 squared, so 9 to 16. And we do know the difference. The difference of the two areas is 7 times 1, so 7. And look at the two numbers. The difference is exactly 7. That means the area of triangle AFG is 9, and the area of triangle ADE is 16. Alright, so now we already find out the answer. The area of this trapezoid, the DBCE, is equal to the area of triangle ABC minus the area of triangle ADE. So we use 40 minus 16, that is 24, which is option E. Alright, let's go to the last one. A 3/4 sector of a circle of radius 4 inches together with its interior can be rolled up to form a lighter surface area of a right circular cone by taping together along the 2 radii showing. So what is the volume of the cone in cubic inches? Okay, so first of all, let me try to draw this cone. If you would like to find out the volume, you must be curious about what is the radius of the base circle, and then what is the height, right? What is the height and what is the radius? And in order to find out the radius, let's use the circumference of the base circle. That is 2 pi r. And let's use the original figure. It's equal to 3/4 times pi times the diameter, which is 8, and that indicates the radius is equal to 3. And then I was trying to find out the height. As for the height, you can see there is a right triangle, and the hypotenuse of this right triangle is the radius of these original figures, which is 4. So we just use the Pythagorean to find out the height is 4 squared minus 3 squared, and take the square root of it, which is root of 7. Alright, and now let's try to find out the volume. We do 1/3 times the base area times height. So 1/3 times 9 pi times root of 7. So the answer is 3 pi root of 7, which is option C. Alright, that's all for today. See you next time.